Good afternoon and welcome to the stream. I'm Surf Dude, streaming from South Africa, and today we're going to do a Steam game, and the name of the game is While True Learn, and it is a pretty fun game. It's got some puzzle parts and logic parts in it, and it also teaches children and teenagers to teach computers to recognize objects like apples, or is the apple green or red? Is it a good apple or a apple with a bad piece on it? And things like that. But it is a very fun game, very easy to learn, and as you go the game teaches you more and more. So it is very easy to start off and very easy to learn. And let me start up the game. And hi Chandler, welcome to the stream, and thank you for popping in to say hi. I hope you're doing well. And this is a game, and it also teaches you about computers to teach them some things. So let's get started with the game. And thank you for that cool emote, I really appreciate that. And let's switch to the game and get started. To become a programmer, you must master the art of turning your computer on. Press and hold the flashing triangle and drag the power outlet and connect it with your screen, keyboard and PC. When it's done, press the power button that will appear on the upper right of the screen. Congratulations, you're almost a programmer. So let's connect power to screen and to keyboard. That should do it. Time to cross the fingers and turn the power on. You can see the electricity flowing, and complete. The computer is on. One more step to be a programmer. Here is the programmer. Late night coding. And oops, there is a bug. I'm sure anyone who's ever ran an application or even a game has picked up a bug in the game. And programmer sees mug is empty. Let's go and fill the mug. Programmer looks in despair. And it seems like there is a cat in the story also. While the programmer goes and gets his coffee, let's see what happens. The cat is moving closer to the computer. And this cat can actually type. The cat fixes the bug. When the programmer gets back with his coffee, he has a great surprise waiting for him. His program is working. Let's try that shout out again. And there we go. So there's a shout out. Chandler's a cool streamer, so check him out. Also, suddenly it looks like the cat has fixed the bug. And the build is successful. There's the cat at the keyboard sorting out the bug, and there's the programmer finding the bug has been sorted out. Programmer has got a look of surprise on his face, and the programmer says, "Hey, what did you do? Did you do that?" And the cat just says, "Meow." If only I could understand what this cat has to say, says the programmer. "Meow," says the cat. I guess we'll have to find out a way to recognize your speech. The cat just says meow. And the programmer sets a goal. Goal: cat speech recognition to-do list. Google it on Cat Overflow. So it looks like this guy needs some help. And there's the Google page. Let's see what happens next. And there we go. Surf316 dude. And the Cat Overflow website. How to recognize animal speech. Programmer sends an email out. "Hey everyone, can you believe my cat? That little devil has debugged my code again. He definitely has something to say, so I decided to make some sort of a system or algorithm which would help me understand him. Give me advice, wish me luck maybe. P.S. I'm not insane. My mom had me tested." And Dr. Coder responds, "Don't rush ahead of yourself. Making a device that would be able to detect the cat would be a nice start. You can work with video sounds when the time is right." And he says, "Hey, a couple of days ago, I've been reading about how expert system can be applied for detecting animals and writing chatbots. The newspaper was called Deep News. I'll be sending you my copies once I've done with them." And here we have a workspace. This is where the programming magic and bugs, mostly bugs, is born. To begin, drag an expert system from the list to the node on the right. Drag the connection line from the starting node on the left to the expert system node on the right. Hopefully the reds are going to go along there and all the others are going to go along there. Let's do a test run and see what will happen. Reds and blues come to the expert system. The red filter sends the reds up and it sends all the other colors down. Let's see when we get to the end. And success, final result. Time spent 20 seconds out of the allowed 26. Nodes used of the expert system, we only used one. And developer says, hey again, I've tried that expert system and it hardly makes any sense. Squares are floating from left to right. Is that what all the fuss is all about? Machine learning? Are you guys actually working there? And he says, this is called visual programming, my fellow dude. Yes, this is how it's supposed to work. The expert system analyzes your data from the camera and checks if there's a cat on them. No, it's not what the machine learning is all about. It will get hardcore soon enough. And the developer says, well, I'm not very good at it yet apparently. When do I actually start building a cat translator? Eraser says, don't rush it, friend. You've got to master your machine learning ninja skills first. I'm working as a freelancer and the amount of contracts is crazy. I'll forward you some of the jobs I don't have time for. It will help you get on your feet and earn some cat bucks as well. Check your mail now. And you'll still be paying for the servers though. Dr. Coder says to the developer, noob advice, there's an auto help for each new technology, very convenient. I've turned it on for now, no need to thank me, but you probably want to change your password. My cat talks 123 is pretty obvious. And here we have the task tree. This is a map of your progression in the game. Vertical progression stands for story quests. Horizontal branches are optional. Icon colors stand for different types of machine learning techniques used in respective tasks. Let's click on, we've learned about expert systems on there, applications. And good day, we are from a public school. Summer exams have ended. The results are attached to the letter. Could you process them and predict which of the students will be able to enter MIT? So let's see the reward, 350 cat bucks. And our helper says, data. See these colorful geometric shapes? They represent various kinds of data. numbers, letters, elements of images. In modern world, everything can be turned into data, and machine learning is all about sorting and interpreting that data. Long story short, your goal in the game is to transfer the data from the left part of the screen to the right. These bars show the minimum amount of data that needs to be processed to complete the task. Let's see, we've got green and blue here. So let's drag an expert system, connect it up, and we would like green to go there, and then everything else should go there. Let's do a test run and see what happens. So far it's working fine. Let's see if we get the minimum amount of data and release the program to complete the task. It does seem to be working. And project released. We earned 350 cat bucks. We paid for the cat service 42, so we have 308 left. So let's see. We've done this. Let's do applicants. Let's do errors. And let's check our recognizing cat. We 42% successful. Recognizing cat speech. We only 8% successful. Spanish School sends to the developer errors in database. Hello, we have some errors in our questionnaire data. We can't solve the problem by ourselves. Can you please fix it? So for 350 cat bucks, we say yes. And now we're talking about medals. Your efficiency is measured not just in money, but in medals too. Medals influence your story progression while boosting your self-esteem at the same time. To get a medal, your scheme has to meet the respective time and node limits. You can prove on the results later. And let's learn about the trash can. In game, this node destroys elements. Important detail, no matter how many trash cans you place, they will count for one node in the node limits. And if you click on that for more information, but we won't do that now. In the real world, real data sets have a lot of errors. Filtering out the errors is very important. And it's a skill for all data scientists. And if you want to learn further, you can click on that. But let's progress to the next step. And we have 3 colors: red, green, blue. And we only want red and green. So let's try this. All blues can go to the trash can. Everything else can go here. Let's do a test run and see what happens. All the blues get killed in the trash can, and the greens and the reds that is successful, you get a star. Money spent, time spent, and we've got 500 cat bucks minus the cat servers that we used to do the processing, and we left with 494 cat bucks. Let's do errors in database number 2. Spanish school sends to the developer, "Hello, it's us again. We found some new types of errors made by our users. Please update your program. It will be easier if you use the previous version of the code." There's our reward. And deep news. Non-neural artificial intelligence. Mankind has always been trying to create an artificial intelligence. Before the invention of neural networks, people used expert systems. An expert system is a deterministic algorithm which reproduces decisions of a real person. An example for this is Eliza, the very first chatbot in the world. It was created in 1966 and talked to patients using questions similar to a real psychotherapist. It worked horribly. And here we have, check this out, custom nodes are special nodes containing your previously designed schemes. Press on the middle tab to switch to the custom nodes list. And we only want let's see, red and trash can. Let's see if this is going to work. Choose red and else go there. Let's see what happens. And sorry about that, I'm back again. Launch complete. Let's release the project. 880 cat bucks minus 58. We've got 822 left. So now we have a decision tree. Let's do, we are getting better. Finding a cat in the picture. The developer sends. Hey, is there a way to detect the cat without using expert systems? It works for texts, but with pictures, not so much. Furthermore, the cat just won't sit still. He says that it does not. Try decision trees then. Those are like expert systems, but on steroids. Once you feel comfortable with them, try SIFT. This little devil is way more effective with pictures. It also works nicely when paired with other algorithms. And Dr. Coder says, or you can use nails or glue or Smith. Come on, it's just a cat, it won't fight you back. Joking, please don't use anything I mentioned on an actual cat. Dr. Coder was joking to glue the cat down. And here we look at processing time. Different nodes have different processing rates. This parameter will influence the efficiency of your schemes. Icons on the left indicate the amount of time required for a node to process one element of data. You can see this takes 1 second, this takes 0 0.3 seconds. Decision tree color. In the game, this node compares output parameters, the sockets, with an element's color. If the color is equal to only one socket's color, the element moves to that socket. If the element's color satisfies both conditions or none of them, it goes to a random socket. So this is a bit more tricky. And in the real world, decision tree is one of the basic machine learning algorithms. Each tree knows a limited number of classes. For each element, the tree asks some questions and chooses the class most similar to the element. And here you can still get more info, but we are going on. So we have got 14 seconds. We have got these two elements, red. These are expert systems. But now we can only have one node. So this is our decision tree, and let's think now. And I don't think this is going to work. Let's see what happens. And that is a failure. Let's do that and test. And this was successful. So well done. Now Strange Man sends. Illuminati origins. Good day. I studied an ancient manuscript and books in order to figure out the true story behind the Illuminati secret society. I need to recognize all the triangular shapes in these documents to solve the puzzle. Could you design a program that would do that for me? To decrease or increase speed, click a button on the screen or use arrows A and D and use the space to pause. Sift. In the game, this node compares shapes. If an element shape matches the designated shape, it goes to the top socket. Others go to the bottom socket. In the real world, scale invariant feature transform is one of the most powerful non-neural algorithms for detecting features on pictures, which is essential for image recognition. SIFT is very fast and capable of recognizing simple objects and patterns. Again, there is more info. Let's carry on. And here we have the SIFT. We have got one node of 2. So we would like only that. And let's put a trash bin over there. Let's test this and see what happens. So far, it's working. Very well. And success. Well done. And we've got 1,000 cat dollars. Startups. Working for the man feels too easy, boring, or soul-sucking. Aim for the sky and become the CTO of a startup. In the world of savage market laws, it's either sink or swim. Will you get rich or bite the dust? It's worth trying anyway. So let's see. Should we try the Pizza Shack or the Chicken Escape? Let's try Chicken Escape. Chicken Egg sends to the developer. Hi there, my name is Sarah. I own a small technology farm. Our distributors demand supplies of eggs of different kinds. It takes a lot of time to sort them manually. That's why we've decided to automate the process. We have all the data about the egg parameters, but we need an algorithm which will work out without human assistance and with high accuracy. Here we have the eggs data, circle, square, and triangle we need to sort. We can have 2 nodes, so let's do 1, 2 nodes. First the circle, then the square, and triangle should go here. Let's see if this will work. I've got a feeling that we could run out of time. Because we have got 75 squares. So let's see, and complete. We did it. Accuracy 100%, and we got more than what we needed for the occupancy. So 1000 cat bucks minus the cat servers cost, we get 973. Let's go with crowd. Let's go with organization or optimization. Optimization of code. It's us again. We hope it's our last request for you. We've changed our database system. Can you update your code one last time? We need it to work faster. So let's have a look at making this faster. Red goes there. Other colors to trash. Let's do the test run. And low accuracy. Let's try this instead. And we'll see if the red, I think we have run out of time. So we need to make this faster. Let's do this. And that. And then this. And we made this go very fast so that all the numbers would get through, and we have achieved success. Let's release the app and we get our money. Let's do Medix. Medix sends to us, greetings. Our company is manufacturing all organic natural painkillers. They are used to decrease suffering, mood improvement, and coping with eating disorders. Known side effects include dilated pupils, diarrhea, physical and mental addiction. Are caused by human factors. From time to time, our workers pick the wrong plants because they look like medical herbs. We'd like you to design an algorithm that would sort the herbs out by the petals' colors. And here we have the different colors. Let's think about how we're going to do this. We want red and green, green and blue, and red and green, and we can have 3 nodes. And blue can go here. Let's see. This is a bit more tricky. So it's not. Let's put this on blue. And let's do that and see what happens. I ran out of time, so let's think about this. This guy is a bit slow, so let's do this here. Let's see. Just test this one. Green and red goes along there. Okay, let's stop that. So green, red and green. And here we want don't want red, we want green. And there. And here. Let's try that out and see what happens. And we have to fix something. So this is working, this is not working. So let's go here. And here we want red. And green. Let's try this out. And see, the top one's working nicely. The bottom one's working nicely. And we have a problem because this guy is not working like we want. This one is, and this one is. Actually, we can still have one more. So let's try this. Red and green could come here. And blue and green could come here. So let's do blue and green. Red and green. Green and blue. Blue and that doesn't make sense. Let's try that. Red and green. Red and blue. Okay, red and green. And let's see, blue and green. Let's try this. And let's see if we are and we still haven't got what we need. This guy is working very well. Let's try this here, and I never knew you could do that. So let's try this over here. Over here, red and green goes to the top. Blue and green goes there. Which is fine. Blue and green goes there. So it's this bottom one that is the problem. We need more colors in here. Let's take this off. And maybe This is very tricky. Red and green. We've got our 3 nodes here. Let's try this. Any can go here. Here we're going to have red and green. Here and here we're going to have blue and green. There. Blue and green, red and green. Here we're going to have red and green. Let's run that and see if we've got the puzzle. And so far seems to be working, and we've still got the gold medal. We've got the silver medal, and we got a silver medal there. So well done. Got that right. Success. Money spent. We've got 839 cat bucks. And let's do cloud psychology. Good day. Our company is making a research on cloud psychology. We need an algorithm which would be capable of defining a person's type based on certain behavior patterns. This way, we will be able to quickly identify dangerous individuals in the crowd and prevent unpleasant accidents. We have identified the parameters to work with, but we need an experienced developer to write the algorithm. So here we have people behavior data, and we want circles, squares. Squares and triangle. And let's see, 6 nodes. And let's see what options we have. Let's say shifter. So let's do let's think carefully here. We would like here we want squares and circles. So let's do that. And let's see if that is actually going to work. Let's run. And the Swift seems to be working well. The Swift is taking the triangles over here. Then next we want colors. Or maybe first we want colors. Let's see. Red and blue. Okay, red and blue. Green and red. Red and blue goes there. Green and red goes here. Next, we would like to get rid of the triangles, and here we would like to get rid of the circles. And let's see how this works out. Is it going to work or not? That is the question. The sifts do take a lot of time. So let's see if this is going to work. Got 18 here. And we've nearly got, low accuracy over here.